In this video, I will explain photodiode. Now, photodiode is one of the application of PN junction diode. So, it's a PN junction diode reverse biased. Now, we will see what is the application of photodiode. Photodiode converts light energy to electrical energy. So, hence they can detect presence of light. I'll give you a simple application of it. Now, see, the cinema directors, they need to know what is the lighting of a particular place. So other person, let's say a person, I am here and I am the director, I need to know what is the lighting, current lighting at Hyderabad. Now that person can say that it's, he can verbally say that it's a good light, a bad light, or maybe intensity is very high, but that is person to person. The higher intensity light and lower intensity light would be different. Now we need a number. What is the measured value in your device that shows that the intensity of light at that place? So higher the intensity, that device will measure higher value, and lower the intensity, that would measure a lower value. Now a person, a director, here I can exactly understand, okay, the value is 10, okay, 10 is suitable for my shooting, so I can go and get my scenes done at there. Okay, so this is how the photodiode is being applied. Okay, so I will explain you exactly what is the working principle of photodiode. Now this is connected in reverse bias, we know, so that this negative terminal has always an affinity towards a hole. Okay, hole to receive here. So let's say when it has a hole, it has an affinity to get this hole, and when it has electron here, it has an affinity to get an electron. This positive terminal has an affinity to get an electron from here, but that is not possible here. That will only possible when there is a connection in between these two. Then I can say that there is a current passing through this circuit. Now here we have a barrier potential, so current cannot pass through this circuit. Okay, now here we have a depletion region. Whatever the light we are going to measure, we will allow the light to fall on the depletion region. Now we have learned the property of photoelectric emission, or learned about the concept work function. Now if it is having sufficient energy, then this photon would be able to take an electron from a bonded condition, from a shared condition, to a free state. For example, I have a silicon atom, silicon crystal in this way. Okay, the electrons are shared, electrons are in bonded condition. These are bonded electrons, or I can say bound electron. Now when the light having sufficient energy falls on this bond, what will happen? Electron will come out if it is having sufficient energy, creating a hole here. Now one more light ray would be able to do the same process. Now maybe one more light ray would be able to do the same process. Now what we have got? We got electron hole pair generation. When the light of suitable frequency falls on depletion layer, we got charge carriers. Which are the charge carriers? Electrons and holes. Now charge carriers are being generated, electrons and holes. Now the generated electron will have a tendency, to recombine with the electron holes, because holes are positive charge and electrons are negative charge. That will immediately try to come back, because the moment it is being generated, it has a tendency to recombine, because positive will attract negative at short distance. But what will happen? I have applied a negative potential here and a positive potential here. Let's say an electron hole pair is generated. That will have a tendency to recombine. But by that time, this negative potential would attract this electron, and the positive potential would take this electron. And even the barrier potential will help for it. See, negative we have here, positive we have. This is a depletion region. With p type we have negative charge, with n type we have positive charge. So the moment it is being generated, this electron and holes are taken towards P and N respectively. E will come to P and holes will come to N. Now this electron from here, that will go to, hole will come to here, because hole will be attracted by the negative terminal and even repelled by the barrier potential. Here holes are attracted by the negative potential, so holes will get a drift to here and electrons will get a drift here. So the moment electron holes are being generated, these electrons are taken to N type semiconductor and holes are taken to P type semiconductor. From there it is taken to, these holes are taken to negative terminal of the battery, and from here electrons are taken to the positive terminal of the battery. Okay, now what has happened? We got a closed loop. Here there is certain value of current being sent across the PN junction diode or through the circuit. We would be able to measure the value of current here. Now higher the intensity, more number of electron hole pairs would be generated, so more amount of current would go. If the intensity is less means only lesser number of rays in a particular square area. Intensity is more means more number of rays would be there. So more the rays, higher the intensity, more electron hole pair generation, and that will leads to a higher current in the photodiode, and lower intensity, lower current in the photodiode. Okay, now what is the application of this? We have learned that this photodiode is able to convert a light energy into an electrical energy. So current would be in this direction, from positive and to negative. One application I have told, in cinematography it would be used. Next application, burglar's alarm. Burglar alarm. Okay, let's say we have a high security door. If at all, if any person approaches the door or come near to this door, or if some person opens the door, we need certain alarm to be activated. So what we will do, we will keep a sensor here, and this sensor would be sending infrared rays. Why we are using infrared? Because infrared is not visible to human eye. If we are keeping red color bulb or green color bulb, we can see that there is a sensor working. But if we are using an infrared ray, the light would be going in between this, but we can't, our human eyes can't see infrared ray. Okay, so one person, that person can't see infrared ray, but lights are emitted from here, and we are keeping a photodiode here. So what will happen? These infrared rays would be captured by photodiode, and this photodiode would be sending current across. So always there would be a current in this circuit, so that this, understand that there is no person in between. See, this is an infrared emitter. From here the infrared are sent to photodiode. Photodiode catches the light, and this light is being converted into an electrical energy. Now the current is sent across. Now we will program this circuit in such a way that whenever there is no current in the circuit, it means that some obstruction is there near to the door, or someone is trying to open the door. Okay, because the light will not reach here. See, if a person come in between, what will happen? This infrared ray cannot pass through the person's body. So if it cannot pass through the person's body, this photodiode will not be able to get the infrared rays. In that scenario, photodiode is not provided with light. In that scenario, current won't be there through photodiode. So we will program a circuit that whenever there is no current, alarm should be activated using a plunger. So what will happen? This will blow alarm. So everyone would be acknowledged, and we can avoid theft in this case. Okay, so in burglar's alarm, what we are going to use? We are going to use photodiode. When there is no obstruction, light from infrared source will fall on photodiode. Current is closed circuit. There is no alarm activated. When any obstructions are there, what will happen? This circuit would be activated with no current and giving out alarm. Okay, so this is one application. Next application is in malls. We have seen devices like this. So the security will ask us to move through that rectangular frame. So what is happening here, there are infrared radiations coming out, and here we have a photodiode. Now these radiations are taken by the photodiode and activating a circuit connected with the photodiode. Now whenever a person is passing through here, what will happen? He will break this. So for that moment, the light from the infrared source would not fall on the photodiode and this circuit won't be closed. There won't be any current in the circuit. So in that scenario, it would count down as one person gone. Now next person comes. So let's say person has passed. So for a moment there is no current, then again current. Okay, now when a next person comes, let's say here is the infrared source, I have cut the signal, then I am passing. So one more count. Again different person comes, next count, next count, next count. At the end of the day, with an indicator here, person, the officer would be able to measure how many person have entered the mall for the day. So counter in malls, so shopping malls. Next thing is not counter, the currency counter. Currency counter. Next thing is, there are multiple applications for this. Counter in malls, not counter, burglar's alarm. Yeah, many are there. So you should learn at least 3 of the application of photodiode and the working principle of photodiode. Okay, thank you.